Welcome to question 5 of the 2010 Mathematical Methods Exam 1. In this video we will be looking at the solution and examination advice for this question. A reminder that this video is in no way endorsed by VCAA. For question 5 we have x being a normally distributed random variable with a mean of 5 and a variance of 9. And z is going to be the random variable with a standard normal distribution. And we'll unpack that one a little bit more in a moment. The first part, A, asks to find the probability that x is greater than 5, which is just the probability that x is greater than its mean. So we're going to start by drawing out our normal distribution, which has that bell-shaped curve to it. And we know that that mean, which is also the median and the mode, for this one is 5. So that was given to us in the question. And then the probability that x is greater than 5 is the area here. And because this bell shape is symmetric and 5 is the centre of it, we know that this probability is simply equal to 0.5. So that is the answer for part A of this question. So this question was reasonably well done by students, with 72% of students getting it correct. Those that didn't get it correct often tried to consider a discrete distribution rather than the continuous normal distribution which was given in the question. For part B, we're asked to find B such that the probability that x is greater than 7 is equal to the probability that z is less than b. And a reminder that z was going to be our standard normal distribution. So for this, we've got two different distributions, x and z. So we're going to draw them just down here on top of each other. So they're two bell-shaped curves. So there's our first, and here's our second distribution. And I've drawn them so that they roughly line up with each other. So if this is x, it's normally distributed with a mean of 5 and a variance of 3 squared. So 3 is the standard deviation. For this one, we know that it's the standard normal distribution, so z is normally distributed with a mean of 0 and a variance of 1 squared, so the standard deviation is 1. So that means that this value here in the middle, or the mean, is going to be 5, and down here, that same position is going to be 0. And now we're dealing with the probability that x is greater than 7. So on this curve we have 7 here, and the probability that it's greater than 7 would be that area under the curve. And on our standard normal distribution, so that's z, we're looking for a value of b, so that the area under the curve that's less than b is equivalent. So that means that our b value would be somewhere around here, and this area would be equal. So to help answer this question, we're going to actually need to standardise. So that means that our z value is going to equal x take the mean over the standard deviation. So for this question, our z value is going to equal the x value of 7, so that's this value here, take away the mean value, which is 5, divided by the standard deviation, which is 3. So we know that if the variance is 9, the standard deviation is the square root of that. So the standard deviation equals the square root of 9, which is that 3 we were just talking about. And if we find that value, we get 7 take 5 is 2 over 3. However, that 2 over 3 would have been this value here, but we weren't looking for the probability that it's greater than 2 over 3, we want the probability that it's less than b to be equivalent. So using symmetry, we know that b must equal negative 2 on 3. So therefore, our answer for this question is b must be equal to negative 2 on 3. So from the examiner's report, we can see that approximately a third of students got this correct, with almost half receiving no marks for this question, which is a little bit concerning. It stated that most students realised that a transformation to the standard normal distribution was needed, but many substituted the variance instead of the standard deviation into that formula. So that's why we were talking about that square root of 9 gave the standard deviation of 3, which needed to be put into this position here. The examiners also noted that the symmetry properties that we used in this question eluded many students. So that's where we found the b value, instead of being 2 on 3, needed to be negative 2 on 3. And setting up some diagrams in your working like we did on the previous slide can help to make sure you get that question correct.